Water quality, total phosphorus, taking a look at what is total phosphorus, state of the bay. We're going to understand what's it measured, why it's important, was it high or low, reducing nutrients, and where the nutrients go, and just taking a look at the pertinent information of this. So, starting off, what is measured? Aquatic ecosystems need nutrients such as phosphorus to thrive, and phosphorus exists in different forms in water and can be dissolved in balance to particles of soil and other materials or contained within living or decaying plants and animals. And dissolved phosphorus is easily used by plants and algae and is typically found in low concentrations in unpolluted water bodies. Total phosphorus is the measure of all these forms of phosphorus combined. So why is that important? Because it's an essential nutrient for plants and animals to make up the aquatic food web, and plankton, also known as microscopic algae, and aquatic plants require phosphorus. Now, phosphorus can be seen in the foundation of food web. You can see this right here, supporting higher levels of organisms, zooplankton, crustaceans, small fish, and top predators. And it's also an indirect indicator of the solubility of water of recreational activities. As such, changes in TP affect algae growth, water clarity in turn affecting swimming, boating, fishing, aesthetic enjoyment. And that's why it's important. How do you know if the nutrients are high or low? Well, the concentrations of nutrients in Lake Depend on how shallow it is, how warm it gets, and how many nutrients it receives from the surrounding watershed. Organic materials from land erosion or runoff, for example, and phosphorus is much typically higher in the spring because of snowmelt in rivers and streams, which carries nutrients into lakes. And some forms of phosphorus is consumed during a spring and summer, as phytoplankton species use it to grow. You also have nutrient-rich lakes known as eutrophic, and eutrophication is when too much happens, and nutrient-poor lakes are also called oligotrophic. The best examples of these are Lake Erie, Lake Superior. The former is a shallow and warm. You can see the outlet of the Key River into Georgian Bay, while the latter is deep, and Lake Erie gets high nutrients inputs from surrounding agriculture and human development. Lake Superior gets much less, and there are many factors at work, including the geology, type of rocks and soils, hydrology, water flow, and the natural presence of phosphorus and the internal load. We can also see the offshore deep waters of Georgian Bay and the total phosphorus levels with a provincial target of 5 micrograms per liter. And it received nutrients that are brought from the watershed from many rivers, including French Key, Mascoute, Manchtuan, Sangawa, and Sanguine, Moon, and Makwash. And we can actually see natural sources of phosphorus: soil and organic matter, spring runoff, wildlife waste, and atmospheric deposition. And some human sources of this is wastewater, detergents, and soaps, runoff from fertilized lawns, runoff from agriculture, falling septic systems, and atmospheric deposition. Now, how do you reduce the nutrients? Too much phosphorus supports rapid algae growth, which can appear as blooms or murky scum, or HBAs. So oxygen levels in water decline as algae decompose, and these algae blooms make water less attractive for boating, swimming, and lake water and drinking, and they're also harmful to fish and other animals. And the algal blooms can be composed of cyanobacteria or blue-green algae, which can have toxins dangerous to both wildlife and humans. Since the 1970s, people in Ontario made efforts to reduce phosphorus loads to surf water, and the nutrients from sewage plants have been greatly reduced as they're fewer sources of this phosphorus. How's it measured? Environment and Climate Change Canada, the Ministry of Environmental Climate Change, like partners, they also have different councils as well. Now, where do the results go? It's algae blooms 15 to 20, Georgian algae blooms 5 to 15, and Georgian 2 to 5. And we can 5 when nutrients disappeared, and what can you do? The biggest thing, though, you can do is to test it, and that's why it's important to know how much total phosphorus is in your water.